Okay, so in front of us we have got two circuits. On the left we have a series circuit, which I'll be making notes on here in this whiteboard, and on the right we have a parallel circuit. And I just want to talk you through what each of these things mean. In a series circuit, you will, if you have any components, then they're going to be wired into the same loop. So you can see here that there is a loop there. So series circuits are singled loop, which means the components come one after the other. So the flow of charge will pass through the first component and then through the second component, and then it will lead right back up to the cell, the battery, or the power pack. In a parallel circuit, you have two loops. So you can see here that this is one big loop where we have the flow of charge splitting up and moving around the parallel circuit before rejoining and going back to the source of the charge, the source of the potential difference, be it the battery, the power pack, whatever. Now we're going to be looking at three things. We're going to be looking at the current in series circuits and parallel circuits, the voltage, and how the voltage is shared out among series circuits and parallel circuits, and also then the resistance. Now we're only going to touch on the resistance for now. Right, so let's start. So we'll start off with current. Now that whiteboard's going to disappear, but it'll come back later on. This is a mobile ammeter. So wherever I put this little arrow here, it's going to tell me the current, the intensity of current, the rate of flow of charge in any point in the circuit. Now my 1 ammeter here measures a current of 0.45 amps. Anywhere I put this mobile ammeter on my series circuit will show me the same current, 0.45 amps. So we say that the current in a series circuit is always the same. We contrast that with the parallel circuit. Here I've got 1 ammeter showing 1.80 amps. And then we see that the current changes. So in this top circuit, in this top bulb, the current is 0.9 amps, and in this bottom bulb, the current is 0.9 amps too. So that's the way that it splits. However, what happens is that when the two junctions come into contact again, then the current goes back to its original amount. So it started off as 1.80 amps, and it's 1.82 amps again, so we say that the current is conserved. We say that the current splits at a junction, but then it comes back together at the next junction and is conserved for the rest. So I'll make a couple of notes on that. In a series circuit, the current is the same or identical across all components, and in a parallel circuit, the current is conserved. Now to look at voltage, I can't use my ammeter. Instead, I'm going to have to use a voltmeter. Now, when you first look at these bulbs, we see there are two bulbs here in this circuit and two bulbs here in this circuit. Looking at the brightness, you'd think to yourself, well, this battery then must have more voltage. And we could look at that by placing our voltmeter leads. Now, our voltmeter always has to be plugged in parallel, which means it will make its own loop. So my voltmeters are always in parallel. Here it's telling me that this battery has got a voltage of 9 volts. And if I look at this other battery, it's also 9 volts. Now this appears a little bit confusing at first because we can see that in my parallel circuit, my bulbs are more bright. In my series circuit, my bulbs are less bright. That's because the voltage is the same across all the components in a parallel circuit, whereas the voltage is shared with all the components in a series circuit. And just think about this. A volt is a joule per coulomb. So 1 volt is 1 bit of energy for every coulomb of charge. We can see our electrons. We can imagine each one of those little bubbles is a coulomb of charge moving through my light bulb. Because these same packets of charge have to move through two components, then the joules per coulomb, the voltage, will be shared between those two bulbs. Here, each of my coulombs of charge are carrying 9 volts, so that's 9 joules per coulomb. And each of those coulombs of charge just have to go through one bulb, which means the total voltage will be the same if you have identical components across both loops in the parallel circuit. So we'd expect to see this bulb would have a voltage of 9 volts, and that's true. And the voltage down here will also be 9 volts, and that's true. So we'll say that the voltage in a series circuit is shared among the components, and in parallel circuits they'll be the same. Now this is only true when we have identical components or identical loops. So if each of these bulbs, if there were 2 bulbs here, then that wouldn't be the same thing, but it's a good rule to have. And the last thing we had to look at was resistance. And here's where it gets a little bit confusing. My equation for resistance is voltage over current. And it's hard for us to measure the resistance unless you use something called an ohmmeter. We don't have those at school, so what instead we do is we use my voltmeter to measure the voltage and my ammeter to measure my current, and I divide those two amounts. In a series circuit, if you add more components or more resistors, the resistance increases. So if I was to draw a resistor and a resistor and a resistor, this would be R1, this would be R2, this would be R3. If they're in series, then my total resistance, which we call R total, would equal the resistance of 1 plus the resistance of 2 plus the resistance of 3. It's a little bit different in parallel circuits. So if I have one resistor and another resistor and another resistor, and I call these again R1, R2, and R3, we have to use a different rule. Now, this we'll only ever find in higher tier papers, but it's good to know anyway. In parallel, we use 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And again, this seems a bit weird, so we use more resistors, and then this is in a parallel circuit only. More resistors, it's actually going to decrease the total resistance. And why is that? Well, if we think about electrons flowing through these wires, if I have a certain amount of current here, this current has got more paths to travel through. Because there's more options, more choice, then the current's actually going to flow faster. The general rule of thumb is that the total resistance in a parallel circuit will always be smaller than the smallest resistor. Like I said, we only see this in higher tier, but it's good to know. So, in this series circuit, if we increase the number of resistors, then we actually increase the total resistance. Parallel circuits, if we increase resistors, we decrease total resistance.